In today's video, I would like to introduce a very nice problem of Burkina Faso Mathematical Olympiad 2001. It's an African Mathematical Olympiad. Here is a following information. Find all positive integers n such that we have this following setup: n cubed plus 3 is divided by n squared plus number 7 is positive integer. Okay, so our goal, we are going to determine n as a positive integer in order to have the whole thing as an integer. Okay, in fact this is a very nice problem, but it's a little tricky, but it's not too bad. Okay, so I would be recommend to give it a try to this problem prior getting to the solution. So go ahead, pause this video when you come back to see the full solution. Okay, now let's jump into the solution. We have the following expression is a positive integer equivalent, which means n cubed plus number 3 is divided by n squared plus 7 equals m, or is a m positive integer. Okay, are going to solve simply this equation, but the problem, we have n cubed in numerator and we have n squared in denominator, so it will be more challenged to solve this equation in this way. Okay, we need to transfer this expression into another expression where we can conclude our solution. Okay, at this moment we are going to solve this equation simply. So we have n cubed plus 3 equals m is multiplied by n squared plus 7. This one equivalent. I'm going to take n term to the left hand side of this equation where we have n squared as a common factor. Okay, so I will have n cubed minus m is multiplied by n squared equals 7m minus 3. Okay, by taking number 3 to the right hand side of this equation. So now I'm going to take n squared as a common multiplier. So I will have n squared is multiplied by n minus m equals 7m minus 3. Okay, at this point the left hand side of this equation we have a combination n and m, but the right hand side of this equation we have m. So we're going to use a trick by adding minus 7n on both sides. I will have n squared is multiplied by n minus m minus 7n equals 7m minus 7n minus 3. So the reason I'm doing this one, because I'm going to take 7 as a common factor, I will have m minus n on the right hand side of this equation. In the left hand side of this equation we have n minus m as well, so I need to extract the common factor on both sides in order to have m minus n as a common factor. Okay, so we'll have 7 is multiplied by m minus n minus number 3. Up to this point it showed up m minus n on both sides. Okay, now I'm going to move over this term to the left hand side of this equation in order to have n minus m as a common multiplier. Okay, so I will have n squared is multiplied by n minus m becomes 7 is multiplied by n minus m. Now by moving over this term to the left hand side of this equation, I'm just changing the sign. In order to have m minus n, I get n minus m. Okay, then I'm going to move over also 7n to the right hand side of this equation. I will be left with 7n minus 3 like this. Okay, now it showed up n minus m as a common factor, so this one is giving us n minus m is multiplied by n squared for this term, for the first term. The second term is multiplied by 7, which is plus 7 equals 7n minus 3. Okay, so I'm going to divide both sides by n squared plus 7, so I will have n minus m equals 7n minus number 3 is divided by n squared plus 7. Okay, if you take a look at the left hand side of this equation, we have n minus m is an integer. That means the right hand side of this equation is an integer as well. In addition to have an integer on the left hand side of this equation, we need the numerator must be bigger than denominator, which means this one must be superior or equal to 1. Okay, now I'm going to solve this inequality by multiplying side by side. I will have 7n minus 3 is superior or equal to n squared plus number 7. Okay, I'm going to move over all this stuff to the right hand side. Is giving us 0 is superior equal to n squared minus 7n plus 3 plus 7 is giving us plus 10. Okay, like this. This one equivalent n squared minus 7n plus 10 is inferior equal to 0. Okay, now we have ended with this expression. What we should do now, this one is telling us this expression is equals to 0 or is strictly inferior than 0. So n squared minus 7n plus 10 equals 0. Okay, so I will have two solutions here. So I will have n equals minus b, which is 7, plus square root of delta, which is 7 squared is 49, minus 4 times ac, which is 49 minus 40, which is 9, is divided by 2, which equals square root of 9, which is 3, 3 plus 7, which is 10, 10 over 2, which is 5. Or another solution, n equals 7 minus 3 over 2, 7 minus 3, which is 4, 4 divided by 2, which is 2. Okay, now we'll have two solutions. I'm going to bring these two solutions at the top and continue solving our problem. Previously we were working on this inequality and came up with these results. We found two solutions when we have n squared minus 7n plus 10 equals 0, and we are going to discuss another case when we have n squared minus 7n plus 10 is strictly inferior than 0. Okay, so now for the next part of the solution, let's set f of x equals x squared minus 7x plus 10. By going through the variation table, I'm going to calculate the first derivative function of this one. So we'll have f prime of x is giving us 2x minus 7. So by solving this equation equals to 0, this one is giving us x equals 7 over 2. So the general picture of this function, so we'll have like this. We'll have number 1 here, number 2, number 3. So 7 over 2, which is 3.5. So we'll have like, it will be here. So I'm going to check the output of this one by inserting this value of x into this function. I will have f of 7 over 2. So this one is giving us 49 over 4 minus 49 over 2, which is minus 49 over 4, plus 10 is giving us minus 9 over 4, like this. Okay, 9 over 4, which is 2 and quarter. Okay, so I will have minus 2 here. I will have upper face parabola. So I have two intersections. The intersections of this function and x-axis it was the solution of this equation. It was number 2 and 5. Number 2 it will be here. Number 5 we'll have 1, 2, 3, 4, 5. Okay, so this is the general picture of this one. Okay, so I will have number 2 here, number 5 here. The solution of this equation in this area. So the solutions of this inequality, x must be belongs to this interval 2 and 5. Since we have n is an integer, which means n belongs to this set, I will have n, will have number 2, 3, 4 and 5. Okay, it's clearly 2 and 5 are the solutions because it was the solutions of this equation. Okay, we need to check only number 3 and 4. So n equals 3 by replacing n into the original expression to see if he's given us an integer, which means is a solution. If he's not an integer, which is not a solution. Okay, so this one is giving us n cubed, which is 3 cubed plus number 3 over 3 squared plus 7. 3 cubes is 27, 27 plus 3, which is 30. Divide 3 squared, which is 9, 9 plus 7, which is 16. This is not integer. Okay, which means is not the solution. Okay, let's check the other case. N equals 4. So n equals 4. By replacing number 4 into this expression, I will have 4 cubed plus number 3 is divided by 4 squared plus 7. 4 cubed is 64. 64 plus 3, which is 67. 67 divided by 4 squared. 4 squared is 16. 16 plus 7, which is 23. This is also is not an integer. Okay, which means we have only two solutions, 2 and 5. If you replace 2 and 5 into this expression, is giving you an integer. So which means the only solutions that we have, n equals 2 and n equals 5. Okay, so I have done this problem. If you are interested in this one, don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.